Welcome. In this video, I'm going to be walking you through the steps of Activity 9, which is this week's activity. This week's activity has two parts to it. The first part involves diagramming on your own piece of paper, and the second part involves answering some follow-up questions on the main part of the activity. In this video, I'm going to be walking you through the diagramming part of the activity, which you'll be doing on your own piece of paper. And you'll basically be recreating what I have on the screen right here, but with your own numbers. So take out your own a blank piece of paper and a pen or pencil and just follow along with my step-by-step description of what you need to be writing out. So at the top left corner of your piece of paper, write out highway number 1, just like I have here, and then underneath highway number 1, write mean speed, and then mu, which is a symbol for population mean, and then write STDEV, and then the symbol sigma for population standard deviation. And then just leave these two numbers blank because you don't know what the mean and standard deviation are yet. And then at the top center of your piece of paper, write highway number 2, just like I have here. And underneath highway number 2, write mean speed and mu again, and standard deviation and sigma again. And once again, leave them blank because you don't know what they are yet. And then at the top right of your page, write highway number 3. And then once again, underneath that, write mean speed mu equals and standard deviation sigma equals. So at this point, the top section of your page should look exactly like my screen, except for the fact that your answers for mean and standard deviation are blank for all 3 highways. So at this point, your page should say highway number 1, highway number 2, and highway number 3, and then underneath each of those, mean, speed, mu, and standard deviation sigma. And these, underneath all of this information for highway number 1, make a graph like I have here at the top left, and use the same tick marks for the y-axis that I have here. So use 100, 200, and 300. And then use the same numbers I have on the x-axis, which are 35 up to 65. So basically your y-axis and your x-axis have the same numbers that my graph has. And once you have the x and y-axis completed, I want you to imagine that on this imaginary highway, number 1, that there are 700 people who drive on this highway every day. It's a population of 700 people who drive on this highway every day. And I want you to imagine that each of those 700 people drives at a certain speed each time he or she drives on the highway. So basically, I want you to imagine that Highway 1 has a population of 700 drivers, 700 daily drivers, and those 700 people have 700 speeds, that they driving speeds. And I want you to make up the 700 driving speeds for the Highway 1 population. And what I'd like for you to do after you make up the 700 numbers is show your 700 imaginary numbers as a graph, like I did here with bars. So notice how I imagined that 200 people drive 45 miles per hour, 300 people drive 50, and 200 people drive 55. And I displayed my 700 imaginary speeds as a graph. What I want you to do is take your 700 imaginary speeds and make them and display them as a graph with bars, just like how I did. And just make sure that they're not exactly the same as mine, because they need to be your own 700 imaginary speeds. And they can be whatever you want them to be, as long as they fit on these tick marks for the x-axis. And once you have your 700 speeds drawn out for Highway 1 for the population, what I'd like for you to do is actually calculate the mean and standard deviation of your 700 speeds. And you can do that by going to Google Sheets. So go to Google Sheets and enter your 700 numbers, And then at the very bottom of the 700 speeds, type in equals average, and then in parentheses, um, put the range of numbers with a colon, and then press enter, and you'll get the average. And I think that you've actually been doing it that way before in Google Sheets in past activities. So just do it that same way again. And then underneath average, in the next box down, type in equals stdev.p, and then in parentheses highlight the range of the 700 values and press enter, and you'll get the population standard deviation. And once you get your mean and standard deviation, just write them out right here. And and like I said, I want you to be making up the speeds of the 700 drivers who drive on this freeway every day. And they can be any 700 speeds you like, as long as they're not exactly the same as mine, and as long as they fit on these tick marks. And I want you to display your 700 imaginary made up speeds as bars. And then after this is done, move over to Highway 2. And once again, I want you to make up 700 speeds. So I want you to imagine that another group of 700 people, population, drives on Highway 2 every day, and I want you to make up their 700 speeds. And once again, make them not exactly the same as mine, and once again, display them as a bar graph, like I did here. And so, but what I'd like for you to do is, just like I did, I'd like for you to make Highway 2 have more dispersion than Highway 1. So make Highway 2 have more dispersion in speed compared to Highway 1. So basically in your Highway 1 graph, the bars should be closer together, and in Highway 2, they should be spread out over a wider range, like I did. And after you do that, once again, go to Google Sheets and calculate your mean and standard deviation for Highway 2 population, and then fill them in. And then for Highway 3, what I'd like for you to do is just actually copy the same bars for Highway 2 and make it the same 700 speeds. So we're imagining that Highway 3, again, has a population of 700 people who drive on it every day, and it turns out that their speeds just happen to be the same speeds as the Highway 2 drivers. And then I'm just doing this for the purpose of the activity, so the standard deviations will be the same. And then once again, well, this time just copy the mean and standard deviation from Highway 2, because they'll be the same two numbers, the same two answers. And then after that, at this point, you've already made up your the speeds of your 700 drivers for Highway 1, and you've made up the 700 speeds for Highways 2 and 3. And you need to make sure that the speeds on Highway 1 have less dispersion, and Highway 2 and 3 have more dispersion, just like I'm showing on my screen. Make sure that your bars aren't an exact copy of mine. And once this part is done, under the Highway 1 graph, make an arrow going down like I have here, and then underneath that write a random sample of 4 drivers, because we're imagining that someone is coming along and observing a random sample of 4 drivers on this highway, number 1, and recording their 4 speeds. So maybe someone randomly selects 4 different times of the day, and at each of those 4 time points, the person goes to the highway and records the speed of the first car that comes by, and that would give the person the speeds of 4 randomly selected cars. This is just an imaginary situation. And after that, make an arrow going down again and write speeds recorded. And then here in parentheses, I would like for you to actually make up the data of the random sample. So just make up 4 speeds and just write them out separated by commas, and just say that these are, and just pretend like this is a random sample of 4 speeds. And these four speeds can be whatever you want them to be, as long as they actually come from your population. So, for example, I couldn't put 100 as a speed because 100 doesn't exist in my Highway 1. And then once you do that, make an arrow and go sample mean as calculated. And then what I'd like for you to do at the bottom is write the word sampling distribution and then means of possible samples. I want you to do this labeling just so you have a better chance of understanding what you're actually drawing out. I want you to do a thorough job of labeling just so you have a chance to reinforce your understanding of what you're actually doing. And underneath that, write mean, underneath sampling distribution, title right here, write mean equals and standard error equals. And don't worry about these parentheses, just leave them off. And because I decided not to make you include the symbols for these. So for the mean of the sampling distribution, what you need to do is just go to the top of the page and look up the mean speed of Highway 1 drivers and just take that same number and fill it in, like how I did for 50. Because remember, the mean of the sampling distribution is equal, when a sample mean is being calculated, the mean of the sampling distribution equals the mean of the population. They're the same number. So just take your number from the top of the page and fill it in down here. And you have to actually calculate the standard error. So what you're going to do is take your standard deviation of your population that you calculated from Google Sheets and divide it by the square root of the sample size, which in this case is 4, and you'll get your standard error and fill it in right here. And you can just round all of these numbers to 1 decimal point, that's fine, like I did on my page. And you're going to be using the shorter version of the standard error formula because the sample isn't more than 5% of the population. So that's why all you have to do is divide, like I said, divide the standard deviation of the population by the square root of 4, and you'll get your standard error. Once you get that number, make another diagram down here of your sampling distribution like I did. First make a number line with some tick marks on it, and at the center tick mark, write your population mean, which for me happened to be 50. And then after you do that, subtract, so this is going to be, at this center tick mark, it's of the sampling distribution, it's going to be your population mean, which might not be 50. Subtract it by your standard error, like how I subtracted 50 by 1.9, and then write out the answer at this left, at the next tick mark over to the left of the population mean. Then take your population mean and add the standard error and write that in the next tick mark over to the right, and you'll have 3 numbers side by side like I have here. So what I did was I just took my population mean of 50 and added 1.9 and got this number, 51.9. Then I took 50 and I did 50 minus 1.9 and I got 48.1. So just do that with your own numbers. So this is basically 1 standard error going to the right and 1 standard error going to the left of the population mean. After that, make an arrow going here to this tick mark, this right tick mark, and an arrow to this left tick mark, and write the words typical over both of them. So basically what you're saying is that this, if the sample mean came out to this number, it would be standard or typical because it would be 1.9 off target, and that's what the standard error equals. So that's basically what you're saying. This is a typical or standard outcome, 1.9 off target, and this is also a typical or standard outcome, 1.9 off target in the other direction. After that, make a bell-shaped curve around the number line just to outline your possible samples. And then after that, look at the number line and try to look for look for roughly the point where your sample mean is located. So remember up here, you made up a random sample of 4 speeds. Take your 4 speeds, add them, and divide by 4 to get your actual sample mean, and then write the word A at roughly the spot where your sample mean falls. So I think mine was 45, 50, 50, 50. When I added those 4 numbers and divided by 4, I think I got about 49. So I put my A at roughly 49. So this is, put your sample mean, write the letter A for your sample mean at roughly the correct spot. It doesn't have to be perfect. And A stands for actual sample mean, or your observed sample mean. And A isn't an actual symbol in statistics. I just decided to use A for this activity. After you plot your sample mean, look across the number line and look for a spot that would be a likely outcome for the sample mean to come out to in this situation. So look for some other point on the number line other than your actual sample mean that's likely to happen in this situation, and write the letter L right there, and like I did here. And what you're saying is that this outcome is likely. In other words, it wouldn't be surprising if it did happen. And it can be, you can write the L at any spot you want, as long as you believe that it would be a likely outcome for the sample mean. In other words, if you believe that the sample mean could easily come out to that number. And when you write L for your likely outcome, just put it somewhere around somewhere around this arrow, or somewhere around this arrow, because this middle area is where the sample mean is most likely to fall. So actually, when you look at the curve on the sampling distribution, if the curve is at a high point somewhere in the middle, that outcome is a likely outcome, and then if the curve is at a low point, like out in the tails, that's a less likely outcome. So just basically look for any spot where the curve is at a high point and put your L there, and that'll be your chosen likely outcome. And then after that, pick a spot that you believe would be an unlikely outcome, and write the letter U there for unlikely. And it just needs to be somewhere where the curve is at a low point, because that's where the sample mean is unlikely to come out to. So basically, A is your actual sample mean, L is an outcome that could happen, and you believe that it's likely to happen in this situation. The sample mean could easily come out to that number, and U is the outcome that you believe the sample mean could come out to, but it's not likely. And like I said, the L can be anywhere you like as long as you believe it's likely, and the U can be anywhere you like as long as you believe it's unlikely. And then after that, just repeat the same process going down for Highway 2. So once again, write out this information, make up 4 new speeds for this random sample of 4 that's coming from this population, this highway. So now, because now we're imagining that someone is observing 4 people from this particular highway. Just make sure that these 4 numbers aren't exactly the same as these 4 numbers, and make sure that these 4 numbers could possibly come from this population of Highway 2, from your Highway 2 population. And otherwise, they can be whatever 4 numbers you want them to be. Then down here, once again, put in your mean and your standard error. Once again, the mean of the sampling distribution is your population mean, and you have to calculate the standard error yourself using that same formula that I mentioned earlier. And then once again, make the same labeling down here with your curve. Draw the curve. Once again, put the population mean at the center tick mark, and then add and subtract the standard error to get the other two tick marks that are nearby, the neighboring ones. And then after that, put an A for for roughly the point of your sample mean for highway 2. And then put, once again, just pick some outcome that you think would be likely and put an L, and pick some outcome you think would be unlikely and put a U, and you're done. So basically, the process for Highway 2 is the same thing you did for Highway 1, just with your new, with a new population, in a new graph, because a new 700 speeds, and a different random sample of 4 from this population. And now for Highway 3, it's going to be the same process again, but with a different sample size. So now you're imagining that someone is coming along and observing a random sample of 25 people driving on Highway 3, and you're going to make up their 25 speeds and go from there. So the left part for Highway 1, the middle part for Highway 2, and the right part for Highway 3 all follow the same steps in formatting. Yeah, and so these are just, I'm just having you think about these 3 imaginary situations. So we have an imaginary situation of sampling from Highway 1, an imaginary situation of sampling from Highway 2, an imaginary situation of sampling from Highway 3. And that's it for this diagramming part. Just take a picture of your piece of paper and upload it along with your answers to the follow-up questions. And just let me know if you have any questions about the activity.